Today's class we're going to cover 4 subjects. First, we're going to define what circuits are. Then we're going to look at Ohm's law that characterize resistors. And then we are going to look at the 2 laws of Kirchhoff, basically the Kirchhoff current law as well as the Kirchhoff voltage law. So this lecture, we're going to define what circuits are. A circuit basically is composed of elements, and these elements can be power sources, resistors, capacitor, inductors, operational amplifier, diodes, and things of that sort. Now these elements are connected by wires. The wires are conductors of electricity. The elements are lumped together by the lumped circuit model. What we mean is that we consider the elements as a single point that contain resistance, capacitance, or inductance. And we consider the conductors as being perfect. Now, what if the wires are not perfect, meaning they may have resistance, or they may have capacitance or inductance? In that case, we model that as 3 elements. Basically, the wire may have, for example, a perfect wire, and then you add an inductor to it, or you add a capacitor to it, or in the case where we have resistance, you can add a resistor to it. So that we refer to as circuit. So how we draw the circuit is called a schematic. So here we have a very simple schematic whereby we have a voltage source with, this is the positive terminal of the voltage source, negative terminal of the voltage source. The voltage source has a voltage of V sub S. And then we have these lines are basically wires of no resistance. And then in this case here we have 1, 2, 3, 4 resistors, and we draw resistors using this wiggling symbol. Now this is a schematic, and the important thing about the schematic is that it represents a circuit. The location of a circuit element in the earlier case where you have the power source or the resistors, where exactly it's located is not very important. What is important is how these elements are connected to the other elements. So the location of a circuit element in a schematic may have no relations to its physical location. You look at the actual circuit on a computer board where a particular transistor or resistor is placed, it probably doesn't look like what it looks on a schematic. We can rearrange the schematic and have the same circuit as long as the connections between the elements remains the same. So in PSpice, which is a very popular tool to enter schematics for a circuit, very often you first define the elements, and then most elements have 2 ends to it, and then you connect one end to another end of another element. So that's how you would define a circuit. Inside a circuit, there's something called a node, and we need to go through the notion of a node very carefully. To find a node, start at a point in a circuit, and from this point, everywhere you can travel by moving along the perfect conductor is part of a single node. Now this is very wordy. What it really means, it'd be easiest to look at an example, and the question is, how do you find the nodes here? Now, if you look at this, you have the elements, which is the voltage source, and 1, 2, 3, 4 resistors. And it looks like, if you do a very simplistic counting, this looks like a node in the usual sense, and this looks like another node. And you may say there are 4 nodes there, which actually is not correct. So the answer, and I can leave it to you to look at it for a few seconds and tell me how many nodes there are. It turned out, after looking at it for a brief period of time, there are 1 node which is effectively, if you move along this wires not entering into elements. So these actually, all these wires comprise one single node. So you shouldn't look at intersection points of the wire to say they are two nodes, but this whole thing is one single node. Whereas this bottom part of the circuit is another node, because you can move along the wires before you encounter an element. There's a second node, and the third node really doesn't look like a node, it's really this node here, because it's part of the wire between the voltage source and this resistor. So the nodes in this case here, there are one node, two node, and three node. More nodes. Well, since the node is composed of perfect conductors, the voltage with respect to an appropriate reference may anywhere in the node is the same. So what we're looking at is the following, and that would be more clear as we talk about resistance. What you have here is that you can take this as a reference node, and sometimes it's called a ground node because literally you connect a wire to the ground, and you can call it a voltage of 0 for the ground. And then this particular node, if you call this node A, then you may say there's a voltage of A, because these are perfect conductor, and therefore the voltage along every part of this wire has the same voltage. So there are three voltages according to the nodes. There are three nodes, and therefore three node voltages, and you can choose one as a ground node so that the other node would have their own voltage with respect to the ground node.